We use ratios and proportions to express the relationship between two or more things. So for example, if I put 2 ounces of cream into every cup of coffee that I drink, I could express that as the ratio 2 to 1, which would say 2 ounces of cream to 1 cup of coffee. I can also write that with a colon, 2 to 1, 2 ounces of cream to 1 cup of coffee, or as the fraction 2 over 1, 2 ounces of cream to 1 cup of coffee. All of these are different ways of expressing the same ratio. Because a ratio is just a relationship between two values, we can scale it up or scale it down. So for example, if I multiplied both of these values by 2, 2 times 2 is 4 and 1 times 2 is 2, so I could write this as 4 to 2, which would mean I put 4 ounces of cream in every 2 cups of coffee. It's exactly the same ratio, it's just scaled up for a larger amount of coffee or for a larger amount of cream. When we express ratios, though, we always want to reduce the ratio to its lowest terms in the same way that we would want to reduce a fraction to its lowest terms. So instead of leaving a ratio as 4 to 2, we would want to change that back into 2 to 1 by dividing both 4 and 2 by the common factor of 2, getting the ratio down to its lowest terms, 2 to 1. We always have to be careful also with the order of our ratio and the units. So when we said that we have 2 ounces of cream for every 1 cup of coffee, if I then asked you what is the cream to coffee ratio, 2 to 1 is not the same as 1 to 2. We specifically said we wanted the cream to coffee ratio, which means that the value for cream must come before the value for coffee. Therefore, if I ask for cream to coffee, the ratio must be 2 to 1, not 1 to 2. If I asked for the coffee to cream ratio, the ratio would have to be 1 to 2. So the order of the ratio matters, and then the units also matter. So if, for example, you're expressing the ratio of seconds to minutes, you might want to convert the seconds to minutes or the minutes to seconds so that you can instead express the ratio as seconds to seconds or minutes to minutes. That's not always going to be possible or necessary, but if it seems like you have really similar units, usually you want to try to convert them into the same unit. So seconds to seconds, minutes to minutes, inches to inches instead of inches to feet or feet to inches. So just try to keep your units consistent. And then we also want to realize that we can have multiple kinds of ratios, so a part-to-part ratio or a part-to-whole ratio. If I say that I have 7 bananas and 3 apples, I could express the bananas to apples ratio as 7 to 3, or I could express the bananas to fruit ratio as 7 to 10. In other words, with 7 bananas and 3 apples, I have 10 total pieces of fruit. 7 plus 3 is 10. The bananas are a part of my collection of fruit. The apples are a part of my collection of fruit. So expressing 7 to 3, bananas to apples, is a part-to-part ratio. But if I want to express the ratio of the bananas to my entire collection of fruit, since I have 10 total pieces of fruit, I would say my bananas to fruit ratio is 7 to 10. I could also say my apples to fruit ratio is 3 to 10. Let's go ahead and look at a couple examples. In this first one, it says you can express your white, black, and blue socks as a 10 to 6 to 2 ratio. If you have 36 total socks, how many black socks do you have? So we have 10 to 6 to 2, white to black to blue, and it says that we have 36 total socks. So since I'm talking about total socks, I want to add up the socks I have here. So 10 plus 6 is 16, 16 plus 2 is 18. So my ratio here, I have 18. But I know I have 36 total socks. So clearly this ratio has been reduced. I'm going to have to multiply this by something in order to get my total sock value. So if I say 18x is equal to 36, and then I divide both sides by 18, I get x equals 2, which means I need to multiply all the values in my ratio by 2 in order to get total socks. So if I write this instead as 10 times 2 is 20, 6 times 2 is 12, and 2 times 2 is 4, I get the ratio 20 to 12 to 4. Now 20 plus 12 is 32. 32 plus 4 is 36. So there's my 36 total socks in the white to black to blue ratio. And it's asking, how many black socks do you have? Well, that's the middle number. So I know that I have 12 total black socks. What about another example here? If 1 inch on a map, so we're looking at a map, 1 inch on a map represents 1 mile in actual space, how many feet apart on the map will 2 towns be that are 10 miles apart? Okay, so I've got 1 inch on a map, so we can call this 1 inch, and this represents 1 mile of actual distance. It says that my towns in real life are 10 miles apart. So I could set up the ratio 1 inch to 1 mile, and then I'm saying that the towns are 10 miles apart. So I would have to multiply this by 10, 1 times 10 is 10, in order to get 10 miles apart. So 10 miles apart, which means I would also have to multiply this by 10. So that would be 10 inches to 10 miles. I could also have set up the proportion 1 inch to 1 mile is equal to x inches over 10 miles, and then cross-multiplied to get 10 is equal to 1 times x, or x, and that would have told me that the towns need to be 10 inches apart on the map. But then realize here that we're being asked how many feet apart on the map will the 2 towns be? Well, the towns are 10 inches apart on the map, and we want to know how many feet they are apart on the map, so we'll put feet, and set up the ratio here because we know that there are 12 inches in 1 foot. So here we're doing the conversion, we're looking at our units, converting units, 12 inches in 1 foot. Now I can cross multiply. 10 times 1 is 10, x times 12 is 12x. If I divide both sides by 12, I get x is equal to 10 over 12, or 5 over 6, which means that the towns will be 5 over 6 feet apart from one another on the map.